Hi, this is part 4 of solar basics, and I'm going to be covering what is AC load like this one and what is DC load in solar power system. So before that, let me get started with the difference between alternating current and direct current. Alternating current is the current that changes its direction continuously with respect to time. Direct current does not change direction, its direction is constant throughout all times. Alternating current does not have a specific polarity, that is, there is no difference between positive or negative. Like as the polarity keeps changing, this bulb works well irrespective of whether it is plugged this way or if I reverse it also, nothing is going to happen. Whereas if you look at a DC load like this 12-volt bulb, then it requires a specific polarity. Now AC has certain other features such as inductance, capacitance and others, whereas in DC there is only resistance. So this is what is enough for this video, and the main other difference is that DC can be generated directly from the solar panel and battery. So if you have a DC load, you can directly run it. Whereas let's say an AC load like this bulb, you cannot run it directly from a solar panel or a battery because it requires a higher AC voltage, which is why you will require an inverter like this one. This is a 150 watt inverter which will take an input of 12 volts, which I am giving from my variable lab bench power supply, and it will convert it into 220 volts AC on the output. Now if you live in North America, inverters will convert it to 110 volts depending on the region. Okay, now people will ask me one question, and the question is, what is the exact difference in the power consumption of AC load and DC load? Why exactly do people prefer DC loads in most situations? Let me show it with an example. Here I have two identical bulbs. Both are 3 watts. This is like 3 watts too, but it runs at 220 volt AC. This is also approximately 3 watts itself, but it runs on 12 volts DC, this bulb. So let me show you the difference on how the power consumption matters. Now what I'm going to do is I'm going to switch to my power supply. My power supply is set to 13.6 volts. Firstly, let me turn on the inverter. Now, if you look at it, the current consumption has already risen up to 0.35 amperes, that is around 350 milliamperes at around 13.7 volts. Now, let us see what is the rating in power. Now, got my calculator here. 13.7 multiplied to 0.35, it is around 4.7 watts of power. The inverter itself is consuming up to 4 watts in this situation without any load on it. Now let's see what happens when I put this load onto it. Now that you see the load is switched on, the current consumption raises to 0.52 volts. Sorry, 52 amperes, not volts, 0.52 amperes now. And let us see what it means for our power consumption. I'm going to put 0.52. Now if you notice it is approximately 7 watts that is being consumed. Now this 3 watt bulb is consuming 7 watts from the solar power system. This is because the inverter itself dissipates a lot of power, and on top of it, the alternating current circuits have a lot of wastage due to series inductance, parallel capacitance, as well as the constant direction change of the AC. So if you have a small solar power system, let's say you are running something off of a small battery, let's say like below 100 watt hours, this dissipation by the inverter will cause a lot of problems. So in such situations, it is better that you have the inverter eliminated and use DC loads wherever it is possible. Now, yes, you cannot use DC loads at all times, but in some cases, if you get an opportunity to use a DC load, it's going to be much more efficient in terms of what it does. Okay, so now I have removed my inverter from the circuit and I'm connected this power supply directly to this 12 volt DC bulb, and let's see how the current consumption changes. Now, if you look at it at 13.7 volts, that is the same voltage, the current is 0.35 amperes, that is 350 milliamps. So when we put it in the calculator, it triggers approximately 4.795 watts. Now, if you look at it, both these bulbs were are rated at 3 watts, but still, even though both these bulbs are rated at 3 watts, yet the problem is that because of the dissipations by the inverter and wastage in AC circuit, your battery and solar panel have to bear a power consumption of 7.4 watts with inverter, whereas the same 3 watt DC bulb you can stick with the 3 watts range itself. Same 3 watts to 4 watts range itself. Basically, in an AC circuit, even though your loads are rated the same, yet the power consumption will be more. So this is one thing to be noted. Okay, now let me give another example right here. I want to charge this power bank of mine, and this power bank will charge from a 5 volt source and by connecting to this micro USB port. Now again I have two options. I can either use this one, which is a DC charger, or I can use this one, which is an AC charger. Now let me test with both of this. Now if you look at it, as usual, inverter has a no load current consumption of 0.35 amperes, and as I connect, now let's see what happens when I connect this adapter to it. Now the adapter alone doesn't consume a lot of power, but let me show you what happens when I connect this over here. Okay, now that I've connected my power bank here, power bank has started charging from this setup. The current draw is approximately 1.0001 amperes, and that, if I put it in the calculator for power consumption, it is 13.7 multiplied to 1.01. Okay, we are consuming around 13.837 watts of power from this one when we connect this to the power bank. Now let me show the same with the DC charger. Okay, now that I have my DC charger connected, let us see the current draw. No load current draw of this DC charger is 0.01 amperes. That is approximately 10 milliamps at this particular voltage. Now let me connect my power bank to this. Okay, so as you can see, the power bank has started charging the same way. One more thing to note, that both these chargers, the AC to DC charger as well as the DC to DC charger, both have a power output of 5 volts at 2 amperes, and even the power bank generally accepts a charge of 5 volts and 2 amperes. That is 10 watts of output power for this, and the power bank will also accept around 10 watts of input. Now if we look closely at the power supply, we can note that the same setup of charging the power bank at 10 watts, there's a current consumption of only 0.4 amperes, that is 400 milliamps, compared to the previous setup where we were drawing 1 ampere of current. Now putting that in the calculator for now, we only have around 5 watts of power that is being taken. we only have around 5 watts of power that is being taken here. So if we look at it, the load is on DC loads are much more efficient in this. One more reason as to why I guess the power bank is not taking 10 watts completely at this point is because it's completely charged, and when it's towards the 85 to 90% charging range, it will not take the complete 10 watts, it will take around 4, 5 or 6 watts. So that is why it was consuming pretty less amount of power on both the setups versus the full 10 watts that it generally is supposed to consume. But still, the results prove to us that DC load is more efficient than AC load, which is why wherever we get the opportunity, we can use the DC load instead of AC load. Okay, so one thing which I would like to show is that the reason why I use this power supply to simulate a solar power system was because it's a little bit like cloudy out here, because of which not able to get a proper output on the solar panel, and the battery is also pretty undercharged, so it's not giving the proper results. But I could show it properly only through this power supply, which is why I use this one. But at the same time, even on the solar power system, it will be about the same results itself. Now let me show you some examples of DC loads that you can use at home. Now DC loads are available in two types. One is they are available at the same voltage as your solar power system. Let's say 12 volt, 24 volt, 48 volts, 72 volt, 96 volt. They are available in that range also. And other than that, we also have USB loads like this one. For example, this USB light, which is also a DC load. Now it may not be very easy to obtain DC loads of higher voltages, but at the same time, purchasing 5 volt DC loads is very easy. It's also low cost, and at the same time it's available just about everywhere. So let me tell you like some 5 volt DC loads that you can use for your application. First thing which I would start off is that get a system like this. This is basically a car charger, and have it connected to the output of your solar charge controller. Once you have it connected, you will have the USB ports here. What you can do here is, firstly, let's say you want some light. You can use this small USB light. It is small, but it's sufficient to give a lot of light. Now, I mean, there is a bit of like daylight through the window, because of which it seems very dull, but it's actually pretty bright when the room is kind of dark. Now, this light is also available in white color. There are also like lights which are like small LED sticks that are also available in the market, so you can definitely check it out. USB lights are available in many types, so based on your requirement you can always upgrade, just that you need to get this high quality car charger. Now, more than light, we require like cooling for us. Now if you have a fan like this one, like I always do, take out the battery from this fan. Don't fix a battery in this. Take out the battery and run it directly off of the 5 volt output from this one. This fan will work perfectly fine with this 5 volt output. The wind is good. And if you have a good quality fan, a very good quality one, which has a high quality battery inside, then you can charge that. There is no problem with charging that. Absolutely no problems there. Now, the other use, like I said before, is that a lot of us have power banks like this. So we can definitely use this 5 volt DC to charge our power banks. These are some basic uses, but at the same time, like there are a lot of USB devices, whether it's Bluetooth speakers or headphones, Bluetooth earphones, and some of the lights also feature their built-in batteries. You can purchase just about any USB load and run it off of this setup, as long as you have a good quality car charger. This way, the runtime will be very high. That's the useful part. So I'm concluding this video for now. Like, thank you so much for watching. Like, comment, share and subscribe. Stay tuned, and I will see you in the next video.